We want to now start having a look at trig functions and taking the inverse functions of trig functions. Now, hopefully, the first thing you're saying is, wait on, trig. If we're just looking at trig functions and trig graphs, I'm not going to get a nice function. It's going to be not going to give me a function. It's going to give me a relation. Good. I'm glad you are saying that. So let's have a look at sin x for an example. Here's the graph of sin x. We know what sin x looks like. We've done this a lot before. And hopefully we're taking into consideration that, well, it's between minus 1 and 1. So it's going through the origin there. It goes through pi on 2, 1. So we're looking at some critical points here at pi. So it goes through minus 1, minus pi on 2. So when we go to draw up our inverse function, yes, we're going to have it going through, that's going to be reflected in the line y is equal to x. The only problem is with this one, we're in the terms of pi here, but in terms of our linear scale. I remember radians and linear scale are the same, so we have to be here in rather than be in degrees. But again, if we're going to graph this up, like 1's going to be, well, that's about 1.5, so about halfway. So it's a little bit over halfway, or a little bit less than halfway. No, a bit more than halfway, because it's 1.5. So it's 2/3, sorry. So that's where our line's going to go. So it's not easy to draw up the inverse function given the sine function. But you're going to have the same right idea. You've drawn it up in class. You've been drawing just general graphs and drawn the inverse function. And you know it's not going to be a function, it's going to be a relation. So hopefully when we ask this question, is it a function? You're going, no, it's not a function. How do we make it a function? That's the key. How do we get a function? And hopefully you're saying, hey, just restrict your domain of your function. And then your inverse then you can get an inverse function. Beautiful if you're saying that. If not, then you need to say that. So what we've got to do is start restricting it. But the key is, where are you going to restrict it? You can look at plenty of these things and go, well, I can have a look here, that if I just get that part of the curve, or that part of the curve, I'm going to do it, or that part of the curve. So that you can take multiple parts of the curve here and restrict our domain in this part to get an inverse function. The key here is like, what do we want to? What else do we want to see? So hopefully you're thinking, hey, I really like to see the origin in it. So what part of the curve either increases or decreases, but goes through the origin? And we're looking here at where it starts to turn. So from the turning point here to the turning point there would give us our inverse, be a restriction that would give us an actual inverse function, because notice it rises the whole way through. It doesn't change. It goes from 0, it's always positive, and goes to 0 there. So when we look to that part, like you could have picked this from here to here as well, because that always falls, or you could pick from here to here, or from here to here. But between minus pi on 2 and pi on 2, the curve will go through the origin. So it gives us that extra reference point. So that's when we look to draw this. That's going to be our restriction. So what's our restriction on the domain of y equals sine x? It's going to be between minus pi on 2 and pi on 2, and then you can see that's our range of our inverse function. And it's going to be between the domain for our inverse function between minus 1 and 1, because that was our range of our function. So that's what we're going to do. We're going to look to have our origin in there all the time with our inverse functions. So notice if I can put it back in these terms as well, we're taking what was in the fourth quadrant, because that part there, if we consider it and compare it to this part over here, which was between 0 and 2 pi, that's the part in the fourth quadrant. This is the part in the first quadrant. So if you remember what we talked about with our use of the calculators and what our calculators define the inverses when we take them in your calculator, then for sine functions, they're going to take anywhere between minus pi on 2 and pi on 2, or minus 90 and 90 if you're working in degrees. That's going to give you, if you put any angle in to your any ratio in your calculator and push inverse sine, that's where it's going to give you, because it gives you values that are negative and values that are positive around the value of 0, around the origin. So that's where your calculator's defined from as well. So if you hopefully remember that when we talked about that in the 2-unit course and what values you actually get. So let's have a look at the cosine and its inverse. So again, there's our cosine curve. So and then our inverse curve. Now you notice like the curves here are just in normal numbers, and our y-axis is in radians with pi in there. So we've already swapped that around. There's y is equal to x, so you can see where it's going to meet up. So as you can see there, it's not it's just an inverse relation as it sits there. What is our curve going to? Where are we going to restrict our curve this time to get an inverse function? Now we can't do what we did with pi with sine, because sine went from minus pi on 2 to pi on 2. Now if we look at that, that's going to give us a relation still. So we can't take the same. Restrict our domain the same as we did with sine. So and you can see that because there's your fourth quarter and there's your first quarter, fourth quadrant and first quadrant. They're both positive. Cosine's positive in the fourth quadrant. So what we've got to do is take the first and second quadrant, because that's where it's positive and negative. We're looking for some values that are positive, some values that are negative, and going through the one full spectrum before we start getting positive or negative again. So there's our restriction there. You can see that we're going to restrict our curve to be that part. So our restriction for the cosine on its domain is between 0 and pi this time. So it gives us our range in our inverse function of 0 to pi. And again, we're going from minus 1 to 1 as our domain for our inverse. So because that's where the cos curve goes for its range. So there's you can see our points there for pi from 0 to pi, and it's working back that way. So that's where our restriction. First quadrant and second quadrant. And again, if you look in your calculator and take inverse sine of 1 on root 2, inverse cosine of 1 on root 2, it will give you 135, or the equivalent for 3 pi on 4 in the radians. But because that's where it's defined. Your calculator is defined for inverse cosine to be between the first quadrant and like 0 and 180. They give you answers there. So that's what you're looking at with those ones. Now, drawing tan graph and inverse tan graph, again, you can see here that we're going to have, because in the tan graph we've got these vertical asymptotes, they're going to have they're going to become horizontal asymptotes for the inverse function. Again, hopefully you're looking going, yeah, we're not getting an inverse function at all for inverse tan. That's not working at all for us. So what we've got to do is restrict our domain again. So again, we'd like to include the origin. So we're looking at that fourth quadrant and that first quadrant. So between minus pi on 2 and pi on 2, because there's two asymptotes there. And that will just give us that curve that's going to go through the origin and keep going. Now notice here, what's the domain of the function here? Well, it's going to be between minus pi on 2 and pi on 2, but our range will be all x values. So notice that our inverse function will have a domain of all x values, because the range of the function was all y values, and our range now is going to be restricted in our inverse function. And there's our tan curve. We get our asymptotes of pi on 2 and minus pi on 2. Then we've got to show those asymptotes. So, and then our curve will rise up and keep getting closer and closer to those asymptotes. So that's what our curves are looking like. So the sine, inverse cos, and inverse tan, and where we're going to restrict our domains of our functions to get our inverses. That's going to be our key every time. So make sure we know what restrictions are. Again, it doesn't have to be that restriction, but that's the general restriction we take, because it includes the origin. All of them, all those restrictions we put on our domain will include our origin in our inverse function graph. So that's generally what we're going to set our domains as, and restrict our domains in our functions, so we get an inverse function when we graph those.